the latest gaming sensation, Flappy Bird.
Flappy Bird.
Why is it so hard?
Downloaded more than 50 million times.
It is the
number one app
in over 100 countries.
It's a global sensation.
And people going crazy by the addictive nature of the game.
Assalamualaikum and hello everyone. For Project 2, we create video game console named Flappy Bird Mad Craze. Before we start, let's introduce our team members. My name is Syarifah Shazrina and my team members are AMIRUL IRFAN, NORDINIE AMIRA and INTAN ZAHIRA. Let's proceed to introduction. First, the project title Flappy Bird Mad Craze is an engaging and creative variation of the traditional Flappy Bird game implemented in C++. Second, this version of the classic arcade game introduces a unique educational twist where players are required to solve math challenges to continue progressing in game. Third, the project was chosen due to the combination of two key interests, game programming and educational tools. And last, Flappy Bird Mad Craze aims to enhance users' problem-solving skills in a fun and interactive way. Next, objectives. They have 4 objectives in this game. The primary objective of this project is to create an interactive console-based game that offers a blend of fun and learning. Specific goals include: first, developing a dynamic game environment using console-based rendering. Second, implementing gameplay mechanics such as collision detection and scoring. Third, introducing math challenges as a means to allow players to continue the game. And fourth, demonstrating programming best practices, including modularity, user interaction, and error handling.
Welcome to Flappy Bird's Mad Craze. This is a main screen display when starting the game. To start playing, enter the name, then press enter to begin. This is game side. Make sure player need to press the space K to make sure the bird keep flying. This is the score and level that the player has achieved. While playing the game, the player may press M to open the menu display, press K1 to resume, and 2 to quit the game. The question screen appears after the player hits the pole. Player is required to enter the correct answer to continue the game. If the player answers correctly, the correct display displayed and the game can continue. If the player answers incorrectly, the wrong answer screen will appear and the player will only have 3 chances to continue this game. The scoreboard screen display after the game over. Player can view the history on their score and the player's ranking position based on the information and data stored in the IO file. Ranking and determined by average score and highest level achieved. This is highscore.txt file is used to store every player's data in the game, name, score, level using IO file. And this will always be updated when the new game are made.
Next, I will be discussing some key programming concepts used in game development, specifically focusing on loops, control flows, arrays, and input-output files. Let's start with loops. In our game, we utilize a loop to maintain the game's operation until a conclusion is reached. The primary loop we use is as follows. In this loop, we continuously check if the game is over. While it is not, the game keeps updating and drawing the screen every 50 milliseconds. The purpose of this loop is straightforward. It ensures that the game continues running until the player completes it or a termination condition occurs, which change is game over to true. As long as the game is ongoing, our game logic runs repeatedly. Next, we have condition flow. Condition statements play a vital role in handling user input and various game events. For instance, we check for key press. If the spacebar is pressed, the bird moves up. If the M key is pressed, the game pauses. These conditionals not only enable player control but also help manage interaction smoothly, such as pausing the game or making the bird move.
Moving on, let's discuss arrays. Arrays are essential for storing data, including visual representation of the game. In our game, we use an array to represent the game screen, structured in rows and columns. This array holds all the visual elements, including the birds and pipes, representing the game layout. The purpose here is very clear. The array allows us to manage the game screen effectively, enabling dynamic updates as the game process, showcasing the bird's movement and the incoming pipes. Next, let's talk about input and output files, which are crucial for managing high scores in our game. An input file is used when we read data that will be processed in our game. For example, we open a file called highscore.txt to read users' name, scores, and levels into our variables. This process is essential for retrieving information from past games, making it possible to display high score. Conversely, an output file is utilized for saving data. In this case, we write the player's name, score, and level to the highscore.txt files. We open the file in open mode to ensure that new scores are added to the end of the files without deleting the existing data.
Function methods play a crucial role in handling a specific task. For instance, the doctrine function is responsible for rendering game elements on the console, dynamically updating the display as the game progresses by taking parameters such as pole position and gate size. Similarly, the ask max question function prompting the player with a max question upon collision with obstacles. The player must answer correctly to continue playing, integrating an educational aspect into the gameplay. Object-oriented programming is utilized to the implementation of game class, which encapsulates all the game logic and data to make the code more organized and manageable. The class include private variables such as load y, score, level, is game over, and is pause to store the essential game states. While the username variables personalize the experience by taking the player name. By centralizing game logic within the class, the structure is simplified, enhancing modularity of the game feature.
For the conclusion, the Flappy Bird Math Quest successfully combines entertainment and education, providing players with a unique gaming experience. By integrating math challenges, the game offers a creative twist, making it both engaging and intellectually stimulating. The project demonstrates sound programming practices with room for additional features and improvements. This game serves as an excellent foundation for learning and experimenting with game development concepts. For contributions, we have 3 contributions. First, Object-Oriented Programming (OOP) effectively organized the game with key elements like the bird, pipes, and game stats encapsulated in classes. Second, math challenges integrate educational value into the game, requiring players to solve problems after colliding with pipes, combining fun with learning. And third, score tracking allows players to track progress, adding replay value. Then, for deficiencies, we have 3 also. First, math questions could be more varied, such as including multiplication or division for added complexity. Second, the user interface could be more interactive and dynamic, adjusting to different console size. And third, the game could include additional difficulty levels or power-ups to enhance variety. And for recommendations, we have 3 also. First, improve the visual representation of the bird and pipes for a more immersive experience. Second, gradually increase the complexity of math questions and gameplay as the score rises. And third, expand the range of math challenges as a player progresses. That's all from us. Thank you for watching.